All right, welcome everybody to the community forum. And so Tim Bergquist is going to be talking about the BARDA Community Challenge. And there's been a lot of discussions about COVID-related challenges. And so it's exciting to see this moving forward. So we're looking forward to hearing about it. Also, I'm not sure if you're planning to talk about it, but also be interesting to learn a little bit about BARDA as such, which is, I think, also of interest to a lot of us. So without further ado, I wasn't sure we'd have those slides, but we do. We always do. Okay, so let's see. So we have 225 sites with the DUA executed, 63 sites with data released, 2.5 million COVID plus cases. And certainly I would say that the importance and relevance of the enclave, given the Delta spike and the fact that it's obvious that the COVID story is unfortunately not ending as soon as we had all hoped, I think will be only enhanced. So I think it's a tremendous source of information. So next slide. Okay, so on to Tim.
Awesome. Thank you so much. So today I'll be talking about the Pediatric COVID-19 Data Challenge. So first off, community challenges are just challenges that are crowdsourced benchmarking efforts that kind of aim to accelerate research by creating new communities around certain research questions, but specifically driving at trying to address important scientific questions. A typical format for a challenge will be the challenge organizers will pose some research question, participants build methods to answer that question, and then challenge organizers benchmark those methods against a hidden gold standard data set that the participants don't have access to. This is so that we can sort of control for the self-assessment bias where people maybe tweak with the data to make their methods look better than they really are. And we can also objectively assess models against each other to truly sift out what is the best method using the available data. So the question we are looking at is which children are at risk for severe COVID? So while most children with COVID-19 are asymptomatic or have mild symptoms, there are some cases in which those pediatric patients progress to moderate or severe COVID-19 with COVID-19 symptoms. This includes multi-system inflammatory syndrome in children, which is a life-threatening inflammation of organs and tissues in those children. Methods to distinguish these children who are at risk are needed to help triage early interventions to improve pediatric patient outcomes. And so to that end, multiple HHS Health and Human Services divisions are coming together to sponsor and coordinate a data challenge around this general question of predicting COVID severity in pediatric kids or pediatrics. So we are announcing the BARDA Community Challenge, or more officially, the Pediatric COVID-19 Data Challenge. This is sponsored by the Biomedical Advanced Research and Development Authority, which is a government institution called BARDA, and they focus on emerging pandemics and emergencies, and to try and they have funds available to them to try and sponsor new research questions into sort of these emerging threats. The BARDA Pediatric COVID-19 Data Challenge is going to ask participants to predict severe COVID in a pediatric population. And with that in mind, we're going to ask two specific questions. So task one is going to be of pediatric patients who test positive for COVID in an outpatient setting, who is at risk for hospitalization. And then task two is of pediatric patients who test positive for COVID and are hospitalized, who is at risk for needing ventilation or cardiovascular interventions. So we've been brainstorming for these two questions for probably a couple months now. And we've kind of arrived at these two questions, specifically trying to balance, clinical relevance. If a model were to answer this question, will it be relevant in a clinical setting? But also, can we actually ask these questions with data available? So we've tested out very specific questions, broader questions, and this is sort of the middle ground that we're finding we have data available for, but we still think are clinically relevant moving forward. So the data that will be available for this challenge is obviously going to be the N3C enclaves data set. We'll be using a de-identified data set to try and make sure that as many people as possible are able to get into the enclave and actually work with this work for this project. In task 1, we have 81,000 pediatric patients who tested positive for COVID in an outpatient setting, but who were not immediately admitted to an inpatient visit or emergency room visit. And then of those, we have 1,400 who are hospitalized within 5 weeks after their initial outpatient visit. So there's some good data there. It's definitely imbalanced, and we're taking that into account with our evaluation metrics going forward. And then for task 2, there were 7,000 pediatric patients who tested positive for COVID, and then who were also subsequently hospitalized after their initial diagnosis. And then of these, 486 patients needed either ventilation or cardiovascular support, in some cases both, which means we have 285 patients who are on a ventilator, 285 patients who are on cardiovascular support. So again, another balanced data set, but there's definitely data here to work with for this question. And then for the data, how we're going to evaluate these is we're going to prospectively evaluate models. So we're going to have everyone working on one branch or version of a data set for training. And then once they build their training models, we'll then freeze everyone's work, new prospectively gathered data, either from new sites or updated data from individual sites that we already have. And then we'll evaluate those models on that new prospective data that's being pulled in. So the evaluation metrics we're going to be using, this will be finalized in the next few weeks. So this is slightly subject to change, but the most of this is pretty established at the moment. So our primary metric, we're looking at F beta. If you're not familiar, F1 is the harmonic mean of precision and recall. F beta just allows you to put different weightings on precision or recall. So based on your value of beta, you can upweight precision or downweight precision. Our secondary metric, or a tie-breaking metric, is going to be area under the precision recall curve. This is specifically because we have imbalanced data sets, and AUPR allows us to properly evaluate that. And then we're also going to be looking at how these models generalize across sites. And in order to do that, we'll be using area under the recall curve, under the receiver operator curve. And this is because AUROC is not susceptible to imbalances across different sites, and so you can properly evaluate methods across different sites with different pediatric populations. And then we're also going to have a qualitative side to this. So there's a panel of subject matter experts that's been helping plan this, and as well as the challenge organizing team. These two groups will be judging submissions in a qualitative fashion based on utility and reproducibility. So utility we're going to take into account things like feature interpretation. How well do your models, we don't want just black box models. We need models that we can understand and know what is driving those predictions. Method clarity, how well is how your method's documented, how clean is your code, how easy is it to understand what's happening. Timeliness of predictions, this is around the idea of utility. So if your models are only good at predicting within 1 minute of when something's going to happen, that's not as helpful as if we can predict 4 days out. And so we have some methods in mind for how to evaluate or how to look at sort of the utility of these models. And then also context utility. From those tasks, you can kind of imagine we're looking at 2 different clinical settings that we'd like to see if we can get these models implemented in. One would be in an outpatient environment, and another would be in a hospital setting. And so we're going to evaluate that as best as we can in the enclave by limiting what data is available to models and seeing which ones perform better under these contexts, under these specific contexts. And then reproducibility. How easy is your model to technically reproduce? If we pull your data, if we pull your model from your output folder into a different environment, and we put in supposedly the same structure of data, how often are our models breaking? Basically, how easy is it to transfer across different environments? Prediction reproducibility. Are your models making the same predictions every single time they are run, or is there a lot of randomness associated with that? And then also document reproducibility. This is kind of in line with method clarity, but how cleanly are your methods documented? How well can we understand? How well could we reproduce your full methods if we had to from scratch? So these are all qualitative metrics. Obviously, it's really hard to kind of tie these down to quantitative metrics. So we're going to have some judging criteria that we're going to walk through as we look at each of these methods. So if you're interested in getting involved, there's a registration process. So the first is to go to Synapse, which is Sage Bionetwork's collaboration platform. There's a link at the bottom there. So synapse.org/peds_COVID_severity. This is our home landing page. The first thing you'll have to do is create a Synapse account, very simple, but do make sure that your profile has your name and institution that will match your N3C Enclave account. And then you can just click the button on this landing page here that I'm pointing to, and you'll be able to just click a button that says register for the challenge. That'll associate your account with the challenge. And then the next phase is you're going to have to create a team on Synapse. And either if you're by yourself, you can create your own team, but you have to have a team. It's a different entity inside of Synapse. And that's how I'm going to be adding people, is by team, to our N3C project, on our Enclave project. So then after that, I'm assuming most people have probably undergone most of this stuff here. But this is mainly for people who are outside the Enclave. But if you haven't, and you just happen to be outside but want to get involved, you'll have to make sure your institution has a signed DUA. Make sure that your personal institution doesn't need IRB approval for access to de-identified clinical data. You'll have to register with the N3C organization, do all the trainings that most people have had to go through. And then this is probably the key step here for everyone on this call. I have a link to the Pediatric Severity Prediction Challenge project. And you'll have to request access to that. But I won't be able to add you to that project until you have an account with all the proper information, as well as the team that's registered, because I'm going to be using your team name to create a folder for you with the proper permissions to kind of lock everything in. So then once you get added, we're going to have more and more of these team files pop up. But depending on what team you're part of, you're going to have access. You'll be able to do anything inside of your team folder. We're going to have, there'll also be a data folder in here with the training data that will be made available to everyone. And then this is just a project workbook. But at the end of the day, what we were going to want from everyone is a project workbook that takes in OMOP tables, does whatever it is you need to do, and then outputs predictions for individual patient level. So we're going to have basically a 2-column prediction file output from your network or graph, and we just want you to predict between 0 and 1 for each patient their risk of either task 1 or task 2's outcome. There will be more once we open up for round 1, there will be more information that I'll be making available on the Enclave site. I'll have a report on there with detailed instructions on what exactly we're looking for, what we expect, and also some other resources that we'll make available to you. So the challenge timeline for this is we've already begun the onboarding phase. We announced it. We mainly push this to organizations who are outside of N3C so they can get going on their DUAs. We're hoping to get a couple external teams involved. But for the purposes of this crew, most of you have done most of the onboarding. You'll just have to request access to the pediatric challenge space. So on September 15th, data will be made available. The training data for task 1 will be made available. And then you'll have until November 19th to train a model and have an output or have a workbook output. You can do anything inside your folder. We're not really limiting what type of cross validations you do, what sort of internal validations you do. That's all up to you. Even what kind of data you use. You can use just the person table if you want. Have fun. But you can pull in whatever data. All the external data should be made available. And you can try and link that to the de-identified data. I know with social determinants of health, that might be a little difficult linking it to 3-digit zip codes, but I've been informed that there is ways you can make that work. You can kind of get some high-level social determinants of health information. And then on October 2nd, we're starting task 2. And then we're expecting 2 workbooks for each of these, or 1 workbook for each task, essentially. And then November 19th, we're going to end both rounds. We expect you're going to have basically an output folder with 2 workbooks. that you're going to have there, and that has to be there by November 19th at midnight Pacific time, and then we're going to lock everything down and stop all editing. And so then after that, I'll be working through scoring all those against code that we've built or that are currently building still, and we'll have then we'll announce our final winners at some point, hopefully by the end of November or mid-December, hopefully before the holidays. And then we'll begin the collaboration phase. And this is where all the top teams will be invited to help draft and write a manuscript describing the methods. Challenge prizes. So there's $200,000 available for up to 3 winners. This is for the either the top 3 teams. It's probably going to be we'll have a winner for task 1, a winner for task 2, and then an overall winner for both tasks. Winners may be eligible for follow-up on funding and in-kind services from BARDA for further technology development and clinical evaluation. BARDA would love to get one of these models implemented into a clinic. Obviously, that's not guaranteed. There's a lot of difficulties with that, but they're ready to, if the top models look promising, they're very excited to try and push these forward into a use case. And then, like I said earlier, inline authorship on the post-challenge manuscript. Everyone who participates will be involved as a consortium author, and then we'll take the top teams as inline authors, or specifically if they help write the paper and help contribute with their methods. So the institutions and researchers involved, special thanks to all these, so that we have a large swath of technical reviewers and challenge administrators. I guess I'm thanking myself here on accident, but myself, Marie Wax, who's at BARDA, Carlos Aguelo, and then a whole host of people who have been putting in their expertise. We have pediatric clinical advisors who are either active or retired pediatricians, and we have some data analysts as well. From Palantir, Andrew Gervin and Armin Mana have been extremely helpful in helping us build out the project space and manage all these resources. Obviously, one of the co-organizers and an expert in his own right, Tel Bennett, and also Richard Moffat as a fellow co-organizer have been very helpful in brainstorming and developing these questions. The sponsoring organizations are BARDA, so the Biomedical Advanced Research and Development Authority, NCATS, and then a sub-department of HRSA is the National Institute of Child Health and Human Development. They are the ones that seem to be very interested in taking these models to the next level. So, and then of course, my organization, Stage Bionetworks, is helping to organize and administer this challenge. So that's what I have. I know that was pretty quick, but hopefully we'll have some interesting questions. Yeah. Are you going to allow for multiple configurations, submissions from a single team? Oh, okay. It's part of NIH as well. Okay. So the description on our website has them as part of HRSA. So maybe I have to go back and look at it. And then also, so I think the final submission is going to be one submission per team. And then, are you providing a data frame that includes some of these derived variables, Boolean encoders showing if they receive ventilation or cardiovascular support? No, yeah. So we will be, for the training data, we will be making available kind of what we consider to be the gold standard of how we're going to define true positives. You are not required to use that in your training. If you think there's a better way to capture data that maybe will make your model more generalizable, you're welcome to use whatever definition you want. But we'll make available basically a data frame of with Boolean indicators about whether a patient falls into our category of true positive for both hospitalization and ventilation and cardiovascular support. Yes, so what's to stop people from running their code on the full data set in the enclave as opposed to your subset of training data? They're not going to have, inside of our project, they're not going to have direct access to the data. They're going to have access to a data set that we provide them. And then what we're also going to do is we're going to be doing our own, we're actually deriving this our data from a limited data set and then putting that through the de-identification process. So the date shifting probably won't be the same as the de-identified data that's made available. And we're also going to be randomizing person IDs so that it's going to be a little more difficult to kind of narrow down in other project spaces what individual persons. Yeah, I know, Joanna. So, but some users have access to full data set, just saying. Yeah, this has always been one of the issues we've been trying to solve, that if you're on the enclave and you have access to a project, you have access to the full data set. And so really the best way we're going to get at this is, maybe people are able to cheat in their training, but we're going to lock everything in before we prospectively pull data in, and then we're going to evaluate on a prospective data set. And so this is the only way we can really see to try and make this as fair as possible. So yeah, that's how we're working this. Do you have a data dictionary of the beta? Sorry. Okay. Do you have a data dictionary of the data you're providing? So we're going to make all the OMOP tables available, and then all the external data sets will be available. The OMOP tables will be, I think, limited to the pediatric cohort. And then, yeah, so it's just going to follow the same format as the normal enclave project space. And then are we going to fix F beta or model performance across a range of configurations going toward precision versus recall? I think we're probably going to fix beta, and we'll make that, and we're going to finalize that in the coming weeks before September 15th. Is the recording of this meeting going to be available? Yes, it should be available. And Joanne, I hope that kind of helped answer your questions. We understand that this is a unique challenge where normally participants don't have access to the data that's being used for evaluation. So this is a unique challenge, along with being in a unique environment. And yeah, this is definitely going to be a test of our challenge management skills here.
Well, it's very exciting. So you say a few more words about how this evolved. Where did this come from?
Yeah, so this actually started under Justin Ganet before he left Sage, and I guess he had been in talks with BARDA. They had been interested in running one of these challenges, and I've run challenges in the past. I think this will be my fourth-ish, and so I was brought in as sort of the N3C's Sage's N3C contact here. And just to start planning, we've been planning this since, I want to say, May. We've been in the works trying to put this together. Yeah, I think BARDA was just interested in I think originally they wanted to build models to predict MIS-C, but MIS-C phenotyping in our current data set is very difficult. It's probably not a good enough gold standard for this kind of challenge. So it's evolved over time to be a little more curated toward what data we have available in the enclave, and like I said earlier, trying to balance that clinical utility versus what's available, because they really did want to build models that would be clinically relevant, and they really want to push that where possible. So yeah, this has been in development since May. So it's actually a pretty quick turnaround for a challenge, but obviously time is of the essence, and they were they wanted to get some, they were hoping that we can use sort of the fall's data. As we start hitting fall, they want to use that data for prospective evaluation, just because I think they're worried more about more Delta surges or other variants coming in and being more severe in children. So I think we're hoping that some of these models that are developed will translate well or generalize to future data as well. So,
great. All right, this is fantastic. Other questions, comments? Okay, well, I think this may be a quick meeting. And anything else on the agenda? Okay,
Joel, that was it for today.
Okay, well, that's fantastic. Well, this is definitely a great talk, and very exciting work, and I'm sure a lot of us will be participating, and it also be a good way of bringing in a broader community as well. So,
absolutely. And I'll also be presenting this on Thursday to the machine learning group. So if you missed something, want to ask more questions, feel free to swing by there. I'll be there I'll have the full hour there as well. So if you have more questions, swing by then.
Excellent. All right. Well, thank you. And See you all soon. Thanks. Bye-bye.
Cool. Thank you.